Welcome to solverfy.
Mass of 1 kilogram is moving with a speed of 4 meters per second and collides, it's moving to the right. And it collides with a block weighing 2 kilograms and moving with a speed of 1 meter per second to the left. After the collision, the block with a velocity of 1 kilogram is moving, it's moving to the left with a velocity of u1, 2.67 kilograms. So here we have to determine the speed of the second block. Let's do this. So let's show the system. So here is the x-axis. The first block is moving with a velocity with a momentum of mv1 to the right. The second block is moving with a momentum of mv2 to the left. So then they collide, and at the moment of the collision, after the collision, first block starts moving with a momentum of m1 u1 to the left, and the second block has a momentum of m2 u2, which we have to determine. Okay, so let's do this. Let's realize the conservation of the momentum. So m1 v1 in the vector form plus m2 v2 vector equals to m1 u1 plus p2 prime vector, where p2 prime is a momentum of the second block after the collision, and p2 prime equals to m2 u2. Okay, let's do this. Let's project all these vectors onto the x-axis. So the projection of the first block of the first part is positive, so it's m1 v1 minus m2 v2 equals to negative m1 u1 plus p2 prime. And here we will determine the sign and the value of p2 prime. So from the equation here, p2 prime equals to m1 v1 minus m2 v2 plus m1 u1. And now we can calculate it. So it is 1 kilogram times v1, which is 4 meters per second, plus u1, because we can group these two additives. So it is 1, so it's 4 meters per second plus u1, which is, here it's obviously 2.67 meters per second. Plus 2.67 meters per second minus m2 v2, which is 2 kilograms times 1 meter per second. Now let's calculate this number. It equals to 4.67 kilograms meter per second. So this sign is positive. It means that p2 prime will be directed to, P2 prime will be directed to the right. So then U2 equals to P2 prime over M2, which is 4.67 kilogram meter per second divided by the mass of this block, which is 2 kilograms. It equals to 2.34 meters per second, and it's directed to the right. So 234 is close to 2.33 meters per second. Therefore, the answer to this question is answer number C. 2.33 meters per second to the right. Now, let's move on to the next question. So in this question, which we need to solve now, the pendulum is, okay, unfortunately it requires the image, but there is no image. So, but nevertheless, let's try to solve it. So, pendulum is released from point A. Point A and point C are at the same height. Okay, let's say we have a pendulum, so that is here pendulum is fixed to some holder, and that's point A. Actually, let's redraw. Yeah, let's increase the height of the pendulum. So that's point A. The length of the pendulum is L. Then here is the ground, which is like here is the zero level. And this length is L. So what do we know here? We know that points A and point C are at the same height, so it means that point C would be somewhere here. So, and we have to choose the correct statement. So here we know, that the h at point A equals to h at point C. Okay, so it means that the first statement is definitely false, because here at these points potential energy is maximum and kinetic energy is zero. So then the first statement is false. Statement B is also false. Statement C is also false. So, and by the exclusion principle, statement D is false because at point A kinetic energy is zero. Then by the exclusion principle, the answer should be answer C. So maximum kinetic energy at point B and maximum potential energy at point C. Unfortunately, I don't know where the point B is, but still that's the solution of this problem. Yeah, please next time submit the question with the image. So I hope I helped you. Thank you very much for your attention.